In this video, I'll show you how to draw reflections in calm water, moving water, and when the object is on a hill. And it's in my book, Ellen's Art for Beginners, on Amazon. In perfectly calm water, the surface acts as a giant mirror. And to find the reflection, find the top of the object, here at the top of a tree, and find out how far it is from the water line. Then draw that same length, and that will give you the bottom of the reflection, which is actually a reflection of the top of the tree. And reflections are always directly underneath the object and upside down. Have you ever noticed that reflections in moving water look like really long zigzags? Moving water creates hundreds of tiny little wave-like mirrors, and because the waves are tilted in slightly different angles, it catches a bit of the light and stretches it towards you. So this reflection of this chair is a little longer than the chair because of the movement of the water. To understand reflections, we have to see the whole process from the side. So the viewer's eye is here on one side of the lake, and he's looking at the reflection in the lake from the tree on the other side of the lake. So light rays hit this tree, and the tree spreads light rays all around, but the one we're interested in is the one that comes down to the water, bounces up at the same angle to go directly to the eye, because that's the only light we see. So that defines the top of the reflection. Now the middle part of the tree hits the lake sooner, and then it goes to our eye. So what the eye sees is an upside down version of the tree. What do you think happens when this green tree is further away from the lake than the red tree? Because this red tree is right next to the water, its light bounces at a wide angle, and this allows you to see the full reflection in the lake. The green tree stands much further back, so only light from the very top of the green tree hits the water to bounce to your eye, while the light from the lower half misses the water completely. And as a result, you see the entire red tree reflection with only the top of the green tree peeking out behind it. Now, what if this green tree were higher up on a hill or taller than the red tree? Well, now the light from the green tree hits the water at a steep angle to go to your eye, and this steep angle forces the green light to bounce off the lake much closer to your eye than the red tree. And as a result, the reflection of the green tree actually stretches further down lower than the red tree, peeking out directly underneath it. Most things are on hills rather than being at sea level. So how do we find the reflection of this lighthouse? You can see it right here. First of all, we need to find the water plane for this puddle. And this puddle in front is actually elevated. You can see the sea below. So it's not at sea level. It has to be higher up. So what we need to do is continue a horizontal plane representing this water level and see where it hits the rocks in the distance. And it turns out that it hits the rocks around here. And once you know that that's the water level for this puddle, then all you have to do is find the distance between the top of the lighthouse to this water line, and that should be equal to the water line and the top of the bottom of the reflection. I'm going to answer two burning questions that you have. Can reflections tell us the direction of the light, and can shadows be reflected? So reflections can tell us the direction of the light only if the object reflected shows that direction. So here, the sun is coming in this direction because it's hitting these light areas. So the reflection also indicates that the light is coming from the left. But in the second one, we know the direction of the light. We see the sun and the shadow, so this is the direction of the light. But in the back, the mountains and the trees aren't affected by the light, so their reflections also aren't affected by the light. So shadows like this one almost always tell us the direction of light, whereas reflections can tell us sometimes, like it does here, but not always. Now, can shadows be reflected? That's my second question here. And in a sense, yes. We have shadows falling on these buildings. And if you look at the reflections, it's just reflecting the dark areas of the shadows. So less light reaches this area. Check out my book on Amazon, Ellen's Art for Beginners, and please remember to subscribe.